I can hear you.
There you go. Thank you. Thank you, Michael. So good afternoon, everybody, and welcome to today's online event called Secret Life of Automation. Wow, that sounds great, actually. So, right, before we get started with the content today, I'd like to go over a few notes how to participate in today's session. The duration of this session will be around 1 hour. The speaker will be presenting 45 to 50 minutes, followed by a Q&A session, 10 to 15 minutes. If you have a question to our speakers, we ask you to please address it through the chat anytime during this presentation, or wait till the Q&A session at the end of the presentation, and our speaker will try to answer to as many questions during this event. Also, I'd like to remind everyone that today's presentation will be recorded and will be posted in our YouTube channel. For those who couldn't join the call, or anyone who wants to rewatch the session and make some notes from the presentation, you can do it so in our YouTube channel. So I just put the link of our YouTube channel into the chat. So now, without further ado, I'd like to introduce today's speaker for this session, Michael Bolton, lead consultant at DevelopSense. He's a consultant, trainer. He specialized in rapid software testing, skill set and mindset focused on high value testing that is fast, inexpensive, credible, and accountable. So he helps organizations, software development groups, and testers to defend the value of the projects and products in any development context, whether it's agile, lean, DevOps, Scrum, or more traditional development models. He provides consulting to executives and managers who want the fastest, least expensive testing that is still completely fulfills the testing mission. He teaches rapid software testing, one of the world's most highly regarded classes on software testing. He also teaches other classes, including rapid software testing for managers, rapid software testing for programmers, rapid software testing strategies, critical thinking for testers, and more. He has well over 25 years of experience in this industry, and he helps people to solve testing problems that they don't know how to solve, and helps them learn how to do that for themselves. And today he'll be sharing some of this knowledge and experience with us. So really excited to have Michael here. Michael, without any further ado, why don't you go ahead and take it away from here? I hope I introduced it correctly, and if I missed something, please go ahead.
Well, it was very grateful, or very gracious. I mean, and I'm very grateful. That was very gracious. So thank you for that. What are we here to talk about today?
So Michael, you can go ahead and share your screen if you like.
Okay, I will, just because you said so. There you go.
There you go.
So first of all, I'm a little bit raspy today. I've had a frightful cold all week, and I've been coughing up very unpleasant stuff, and been in a slightly decrepit state most of the week. So I hope you'll forgive me for that. But there's a bunch of things that I'd like to get clear from the outset. There's a lot of stuff that we talk about in the world of testing, and there's a lot of stuff that we don't talk about. I've had some people who've been very helpful to me in terms of sharing some stories, and I've got some stories of my own, and I'm in the midst of kind of showing some of those bits and pieces, and just describing to you how there is a hidden life that we don't really like to talk about very much. So the first thing I'll say is that this talk is based on my personal experience. It's based on surveys of stuff on the web, and it's based on interviews and chats with friendly colleagues, and some of those people appear there on the screen. There's another aspect of this, of course, which is a kind of selection bias that I have to work with, and that is people who don't need my help don't ask me for help, and the people who really need my help don't ask me for help, and maybe they don't ask anybody for help. That to some degree affects the content here, because stories that we tell amongst ourselves in general. And then for some of you, this talk isn't going to work. You're going to interpret it from your own set of perspectives and biases. Oh, Jennifer, you've just done something really helpful for me, which I wish more people would do, is you've turned your camera on, which I'm really grateful for. Oh, thank you, Curtis.
I was just
Hey,
about to turn it
Curtis.
on, but okay, good.
I
My
recommend you.
cameras are going on. All right, cool.
Well, I appreciate it. Hey, Curtis. We know each other from somewhere, don't we?
Cast, yeah.
From Cast, right. Great. All right.
Sorry, I was eating earlier. I would have had my camera on.
Oh, well, it's all right. We like to see that anyway, one way or t'other. So some of you are going to come prepared with the perception that we don't like automated checking. James Bach and I don't like automated checking, and in fact, we don't mind it. We think it can be really, really useful when it is applied judiciously. Some of the trouble that we've seen and that we're going to see relates to the fact that we see automated checks being pointed at unhelpful levels of the application, mostly when it's pointed towards the human graphical user interface. It seems to us weird and strange a lot of the time to point the GUI or point to tools at interfaces that are designed for humans, and to do rather less of pointing those tools at things that are machine-friendly interfaces. So let's put this on the table here. The idea of some healthy perspectives that we might have about checks. We like checks. We use checks. Checks can help us affirm that the product can work, or if the product has suddenly stopped working or has exhibited problems in ways that are covered by the checks. The things we have to worry about, the thing we have to keep in mind is that testing is really fundamentally about learning. Testing is evaluating a product by learning about it through experiencing and exploring and experimenting. And checking, it seems to us most of the time, is oriented towards demonstration, the idea that a product can work. A lot of the checking that we see is oriented towards demonstrating that the product can work, but that's a long way away from showing that it will work under various kinds of circumstances when the product is being challenged. The other thing that we want to pay attention to is that management is often really dazzled by programmatic checking. It's easy for a manager to look at a screen, see lots of stuff going by, lots of virtual buttons being pushed, and say, lo, there be testing. But we also have to be careful of the fact that a check is inside a testing activity. A check is a subset of a test. It's the part of a test that can be automated. And then Another thing we got to be careful of is that there's a lot of stuff that we tend to keep quiet about. So don't tell anybody. If we're successful in our application of tools and our application of checks, that redounds to a commercial advantage for us. Of course, failure redounds to embarrassment. And so the current status about what's actually going on in the industry is largely unknown. It's secret because we don't want to boast about our successes, and we don't want to confess to our failures. And so a lot of the time we don't know what's going on in other places. So what's not being talked about? Let's bring that up. What's not being talked about in a lot of places, what people actually do in a deep level in so-called test automation work. We also don't talk a whole lot about what people actually do in all kinds of testing work. And we don't talk very much about what people do in development work, what machinery does and what machinery doesn't do, and how our tools could extend our testing superpowers in various ways. So I'm going to jump around between a lot of content in a lot of different talks that we have. I want to get specific about this, and some of you will be familiar with it, perhaps. Some of you not so much. It is important for us to make a distinction between what machines can do and what humans can do. It's important for us to distinguish between testing and checking. It's important not to confuse checking or output checking with testing. As I mentioned earlier, check is only part of a test. It's the part in the middle. A test requires a couple of things that bracket the check. First of all, it requires a human intention to investigate the product for a risk that matters to people. And part of the stuff that goes before the check involves creating some code to operate the product and check specific facts about it. But that fact-checking code has to be designed and written and debugged and maintained and reviewed periodically. Here's part of the secret life of automated testing or automated checking. I don't like saying automated testing. The secret life often doesn't mention the trouble that we take to design, to write, to debug, maintain, and review those checks. In fact, I think that the checks don't get reviewed very much at all. That's my great suspicion. And I can say that, I think, fairly handily, because I hear about companies that say we have 100,000 automated checks that we run on every build. How many checks would we have to review a day to make sure that they got reviewed once a year on average? Anybody do that math real quick? Feel free to unmute and speak up. $100,000 automated checks, 250 working days a year. How many checks would we have to review a day on average in order to make sure that they were all being reviewed once a year? Oh, now let's not all be answering at once. The clamor is indefensible.
465.
Yeah.
400.
Yeah, let's round figures. Let's say 400. 400 is big enough. Is that happening? I don't know. That's a secret. Then after, so there's a lot of maintenance and review work that ought to be done on the checks that isn't being done. And then when a check completes, there's a bunch of extra work that we have to do because no responsible tester will go to the developer and say, hey, guess what? The check ran red, so there's a bug in your code. No responsible tester will do that. The tester will investigate, analyze, look over the outcome, evaluate whether there's a bug in the code or a bug in the check, whether there's, maybe there's a mismatch between the test environment and the product under test. Maybe there's, maybe the code was changed yesterday, so the check that was relevant yesterday and up to date is not relevant today. We don't talk about that very much either. So after a check is executed, a human has to analyze and interpret the result to determine whether red is signaling an actual problem, or to question whether green really means that everything is okay. And then checking tends to be focused on the easy part of testing. What's the easy part of testing? Well, from here we look at Harry Collins, who is a sociologist of science and sociologist of scientific knowledge. He pointed out in an abstract that he wrote for Eurostar about 10 years ago that there are two parts to testing. One is the easy part, the part where we check the machinery, almost literally. I mean, computers used to be machines. The very first computer was actually physical machinery. And you can see there's a crank, and there's some gears, and there's some bearings evidently, and some wheels. And you set some settings on the wheels, and then you turn the crank, and out comes a result. Well, in order for us to trust the result from that, we got to check to make sure that the machinery is working okay, and the cogs mesh together, and the wheels spin nicely, and the bearings all turn, and so on and so forth. But that's not all there is. We've got to also consider what testing is. So let's call that part where we check the machinery, let's call that checking and not testing. Where checking is operating a product algorithmically, mechanistically, in order to check specific facts about it, interacting with the product specifically, algorithmic ways to collect specific observations, applying algorithmic decision rules to those observations, and then relaying the outputs of the evaluations algorithmically. Like this. It'll take me a minute to bring this up on the screen. But here's something that we could do with a piece of software. Let's look at this. This is, now I'm going to give away a little secret. I'm going to get in trouble maybe from James about this, because I'm giving away a secret from our Rapid Software Testing Explored class. Sometimes James does this exercise, sometimes he doesn't. Sometimes I do, sometimes I don't. The issue here is that we've got a program, a little program. I'll zoom it up a little bit so you can see it just that much more easily. This is based on an actual bug that we found in, it was quite a while ago, but it's a kind of bug that's still relevant. We still see this sort of bug in the wild all the time. I'll type my name in here. That's just for logging purposes. The idea here is that there's a page printer for this calendar program, and you can set it up so that the page for your calendar looks like this. Well, the earliest time on the page is 8 a.m. The latest time on the page is 5 p.m. And then it says success, page layout hours are accepted, and the earliest time is earlier than the latest time, because that's what we want. There's a routine, client-side routine, that prints out, or that sets up the calendar printing program so that it displays these nice little ledger lines. And, if you'd want your day to start earlier, you could have your day start at 7 o'clock, and then you could have your day end at, 6 o'clock, like that. And then it still prints out on the page. And look, that one's okay too, because of course the earliest time has to be earlier than the latest time on the page, and the hours can't span midnight, because that would be confusing, right? I mean, if we had this time here earlier than midnight, like this, then it'd be hard to tell if we were referring to, let's say, I know what we could do. We could do this. We could set it up to be, let's say 10:30 at night. Let's say 10 o'clock at night. Imagine what would happen if that printed. And it says an error. The page layouts are not accepted because if it's at 10 p.m. here, 10:30, 11:30, 12 a.m., would that refer to May 11th or would it refer to May 12th? Or maybe this refers to May 11th and then everything after that is May 12th and it would just be really confusing. Nobody prints a calendar page like that. So the latest range we can have, or the biggest range we can have here is 12 a.m. to ending date at 11:30 p.m. And in the exercise, what we're doing is we're trying to establish you can have as whatever starting time or whatever ending time you like, and but it can't span midnight. We can't cross that boundary between 11:30 p.m. and midnight for any given date. Otherwise, it wouldn't really make sense. How should we test this? Well, let's look at the test space. There are 48 half-hour intervals. This is a drop-down, so you can't select anything other than these 48 possible values. And then, look, there's a latest time, and we can't select anything other than those 48 possible values. So how many possible combinations are there here to be tested? Now, Jeff, you're watching, so it seems. How many possible values are available to be tested here?
So in half-hour increments, it'd be 48, right?
48, right? And how many combinations when we consider earliest time and latest time?
47, would that be?
Well, I mean, we can have a 12 a.m. and 12 a.m. that would be invalid. So that would get rejected, but it's a possible choice. Well, like this, we can even show you. There's 12 a.m. to 12 a.m. And that gets rejected as it should, right?
Yeah,
Yeah,
so that's a
okay.
valid case.
All right, so here's a valid case. So it's weird, but there it is, 12 a.m. to 12:30 a.m.
Yep.
Okay. So then we go at 12 a.m. to 1. Right. So if we were to do all of these, how many would there be?
There would be, well, of starting at 12 a.m., there'd be 48, where one of them is invalid and the rest of them are successful.
Okay, good. And then starting at 12:30 a.m., how many would there be?
There'd be 47, so you'd have a 48 factorial.
Oh, couldn't you do, but couldn't you do 2 invalid ones from 12:30 a.m.? We do 2, let's do 12:30 a.m. and we do 12 a.m. That's invalid. And it says so.
Okay, sure.
And also 12:30 a.m. That's invalid and it says so.
Yep.
All right. Okay, so at one point, well, how many would be that then? 48 times 48.
Yeah,
2,304.
2,304. Curtis, high five. Well done.
I used my calculator while Jeff was talking.
There you go. Exactly. I suspected as much. Although, if you know the tricks, you can get to that pretty quickly by saying, let's 50 times 50 minus 49 minus 49. So now we get to 49 squared. And then you can do 48 times 48. So you subtract another 48 and another 48. And so you end up to 2304. There are tricks you can do in your mind quickly to do that mental math. I've never really quite mastered them, but we could do it. All right. So one of the things that occurs to people is, hey, we could automate this. Wouldn't that be cool? A fellow named Michael Mintz came to us a couple of years ago and said to James initially, I want to be, he said, I want to learn to be a better tester, which is impressive because the guy wrote this really interesting library, this really interesting framework called Selenium Base. Selenium Base is, well, here's what happens. You write some code in Python, and you do that using the PyTest framework. And in your Python code, you call Selenium Base, which calls Selenium, which calls WebDriver, which calls the browser. So I guess really what it amounts to is this sort of Jenga tower of code. But, you know, it can actually, it's pretty cool. So let me show you what Michael Mintz came up with in order to test this combination of stuff. Let's see, we'll put it on the screen there. And I will, I've got a little shortcut so that I can get to it quickly. See, that's really good automation right there. That's something where I just press a couple of keys and whoop, thanks to a batch file, I go exactly where I want to go. So I type PyTest, and then I type the calendar test, and there he goes. And we get that started. Now the initial bit of Selenium Base, the bit where it calls WebDriver. Oh, geez, look at this. Here's part of the secret life right here. Selenium Base needed to go get an update to Chrome driver, but, you know, to Michael Mintz's credit, he actually did this. And now look at that. There you go. Some automated checking is happening. Look at that. That's pretty phenomenal. There we go. And you can see he's going through each one of these combinations in turn. He's handling the pop-up, which I think is really cool because that's kind of tricky. And anybody who's done a GUI level automation for web stuff knows that when there's a pop-up that comes up, sometimes it's an iframe, sometimes it's something else. But Michael is managing to grab that and to read it and to parse it. And there we go. We got that thing running away. Now, let me go back to the more static version here, because I had another idea for this. My idea was to whap on the F12 key and to go to the elements in the product right here and to look at what's available there. Oh, you know what? I'll go to the source code files. And in the source code files, I see a whole bunch of stuff. Look, these are the, oh, this is how they're implementing it. That's kind of cool. There's a value here associated with each of the time slots. There's a start time. And so for 12 a.m., that's 1. And then for 12:30 a.m., that's 2. Okay. And so actually what's happening is you're sending in here in calendar.js, there's an index, essentially what amounts to an array, with 0 as being nothing. And then the first element, the item 1 in the array is 12 a.m. and then 12:30 a.m. That's 2, and 1 a.m. is 3, and so on and so forth. And then if we scroll down in here someplace, we find this function called validate times. And it says, if the end time value, which in the case of the default, what were the defaults? Let's see, let's go back to here. Oh, look, there's the default, 8 a.m. If that's 17, and then we go back here. If that's greater than the start time value, we go back here, and we see that these, if the end time value, 35, there you go, 5 p.m., is greater than the start time value, which is 17, then we declare victory. We say that, yeah, it's true. the times are validated. And otherwise, if the end time is less than or equal to the start time, then we declare it's false. Well, I thought I could do something pretty cool with this. I could write a script that would exercise that function on its own. See? And well, now let me bring that up. I'll just go here to PowerPoint, and I'll bring up the code, and I'll put it in front of your eyes right here. See, I wrote some code. Where is it? Oh, well, here's the explanation. I'll just go over what we just saw. So the developer created those two tables, one for the earliest and one for the latest, and so on. And you can see that by pressing F12 in the browser and clicking on sources. And then when the user clicks the submit button, the browser calls a function called intuitively submit. And the submit function makes sure that the username field is filled in, calls one function to log the input, another function to validate it and render it. So there we go. And validate and render calls that validated times function that I showed you there. All right. So here's my idea. Since the that's how validate times work, because I just showed you. So 35 is greater than 17, so the validation returns true. And then supposing we choose a start time of 1 a.m., whose value is 3, and an end time of 9:30 a.m. Well, let's actually go to the browser and try that. 1 a.m. and 9:30 a.m. Let's try that. Really? 1 a.m. and 9:30 a.m. Submit. Click OK. What? What just happened? Wait, it says error. Page layout hours are not accepted. The earliest time must be later than the start time. But wait a minute, 1 a.m. is earlier than 9:30 a.m. And if we go back here and have a look at what that says, because at 1 a.m. that's value is 3, 9:30 a.m. that value is 20. So if 20 is greater than 3, well, 20 is greater than 3, isn't it? On what planet is 20 not greater than 3?
If you're looking at strings.
Welcome to Planet String. That's right. You've probably seen a sorted list that looks like this. These items are sorted in string order. Now, Jeff, you were very quick at identifying that. How did you know?
It's an issue we've had before.
If you have some experience with this, you're on the lookout for an issue like this. But if you've never encountered it before, as indeed had the developer who actually wrote this code. So here's the code again. The developer apparently forgot everything that comes from the browser is by default a string. So in this if statement here, what the developer really should have written is a parseInt function around that. Now, what did I do about this? Well, I had an idea. You know, we could focus on the right risk, but how do we know what the right risk is before we tested? We could try each consecutive half-hour pair, but I had a cooler idea than that. I thought I had this idea that maybe I could write some code to execute that validate and render thing. So I wrote a script. See, my script looked like this. Generate all variations. See, I got two loops. I set them up like this. And there we go. Generate all variations. There you go. And I put that in there. And you know what? I'm going to actually go to the browser right now. And I'm going to hit the F12 key on that. And I'm going to run my little bit of code. Ready? I'll paste it in. There we go. Generate all variations. And hit the enter key. And oh, what just happened? Nothing. Why did nothing happen? And I'm going to tell you live and in person, I actually don't know why nothing ever happened right there, because this is once again the secret life of automation. I've got code. I've run it lots of times before. I know it works. I've seen it work. I've made it work, and yet it's not working. What's going on here? is this because, oh, there's an error message up on the screen? Okay, that's it. Okay, let's do this. There, okay, now I can run my code and look, it's done. It did all 2,304 variations. And notice, by the way, Michael Mintz's script is still running. That's because it's going through the GUI, and the turnaround time for each one of those checks is something like, oh, I don't know, it looks like 1, 2, 3, 4, 5, 6. It's probably doing 4 or 5 of those a second. My script, look at that, 2,304 results in next to no time. How about me? How cool am I for doing this? And it doesn't take very long if we look at this to realize that something is seriously weird here. 12:30 a.m. to 4 a.m., that's rejected. Because you know what I would expect if I were scanning down this thing, I'd expect the first one to be rejected, just like we did with earlier on there. And I'd expect the first 2 of the next set to be rejected, as they are. But then all of a sudden, what? This lump of stuff that's rejected. And then I look down a little farther, and I see a whole bunch of stuff that's rejected now. And then I look down farther than that, I see a whole bunch more that's rejected. So, yay me. My script, Michael Mintz's damn script, is still running at the GUI. My script found this problem in less than a second. Except here's the part I'm not telling you about. All 2,304 combinations in less than 2 seconds. Doesn't take very long to see something seriously strange. But here's the bit I'm going to tell you about that nobody else tells you about. The secret life. I'm not a full-time JavaScript programmer. I've never been one. I'm not doing this stuff every day. If I were, and if I were doing it every day, I'd be a kick-ass JavaScript programmer. I know to program. I've written programs for money since about 1988 or so. But I'm not that fond of it. It's not fun. Every time I program, I feel like I'm being pecked to death by ducks. Unlike other people, I'm going to tell you about my secret life with this. I'm going to tell you about all the mistakes I made. I thought that I could use a ternary operator, you know, the if then else a statement done as a question mark and a colon and stuff. And I thought JavaScript supported it, and it does, of course. But I tried to do it with, you know, without looking it up, but it wasn't working. So wait a sec. I thought, hang on. Just why don't you just write a stupid regular if statement? So, but then I thought, oh, I could embed a function in a ternary operator assignment. Maybe I could have done that. Hang on. Just slow down. Keep it simple. You need it to be simple. Efficiency, elegance, cleverness, none of that is an issue. Just write some dang code. And I got something running, and it didn't throw an error message, but it didn't stop. Why? Oh, well, it turns out I got the, my spelling. It turns out I got the internal syntax of the for loops out of order. Can you believe it? I missed up the second and third terms. Because, well, that's because in Ruby, we don't do for loops, we just do iterators. But I thought that for loops are easy because, hey, I've been doing loops forever. I don't have to look this stuff. Oh, geez, wait a minute. I totally fooled myself. Let things go, and you forget obvious stuff. So I was using interpolated strings wrong. In JavaScript, it's like that, and not like that as it is in Ruby. So I had to look that up. I found it quickly. I changed both interpolated strings. And then I was getting the string interpolation friendly delimiters wrong. In JavaScript, it's backticks, not double quotes. I had to look that up. I didn't notice it when I looked up the previous wrong thing. I fixed the delimiters. I ran the scripts. I changed both the interpolated strings. I should have changed all 3 of them. I forgot one. JavaScript complained that I declared a variable, that I had failed to declare a variable, so I declared it. Then it complained that I haven't declared another variable. I declared that too. It took me 45 minutes to get this stupid little script running, and that's because if you're not doing it every day, you mess up. But if you are doing it every day, your ambition goes up and you run into different problems. And it becomes easy to forget that there might be a simple way to solve the problem. I'm not opposed to automated checking. But what I am what I want to be cautious of is as we do things that are more powerful with our tools, our ambition grows. So we're always at a cusp. Do I do this myself, or do I spend time training a machine to help me do it? So this is like stupid and embarrassing stuff. But here's the other thing. Michael Mintz's script is still running. Still running. And it's going to remain running for a while. Because it's still only at 10 p.m. It'll finish pretty soon. But here's the thing. If you go to this page and you simply pick a bunch of times at random, submit, okay. And if you go like here, 5:30 a.m. and 4:30 p.m. and submit at random, and it says success, and then you go up here and you choose a value like this, 2 a.m. and you go to, I don't know, 4:30 p.m. and you submit, and it says error right away. If you test at random, you'll find this bug within 2 minutes. And we've done this over and over in the class. When people are shown this, we give them a really long, elaborate set of instructions on how to create 10 test cases. And they do that. And we just get them to test at random for 2 minutes. Don't justify every test. What happens? They stumble over the bug within 2 minutes. Now, it's really tempting to write something that runs and takes all this time. And at the end of it, what do we see? Here's Michael Mintz's, the end of Michael Mintz's thing. It terminated while we were paying attention to that last thing. What does it say? It says one passed. Wait a minute. They all passed? One test passed? Ooh. And it took 15 minutes to do that. And what's all this stuff in the log file? In the output log, notice that it doesn't say anything about this. Oh, it does say pop-up status was incorrect for the following ranges. But if I didn't go up to the top and look for that, it might be really easy for me to go down to the bottom and look at this and say, hey, everything passed, everything's green. We're seeing a green bar there, happy, happy. So, a heuristic. Never run an automated check that you don't understand. And then to go along with that, well, there is a counter heuristic which says, do run an automated check that you don't understand if your goal is to understand the automated check. All right, that's just one instance. Let's look at some of the healthier things that we could think about with respect to the secret life. I'd like to show you a new word. The new word is GEMPUB. Here's a new word in a bunch of different fonts. So you get familiar with it. What does it stand for? It stands for getting machines to push buttons. If we want to be really great with automated checking, it seems to me, we've got to recognize that what we're doing is we're trying to get machines to push buttons, and there's a risk associated with that, which people don't talk about. There's a fixation on GEMPUB because testing is misconceived as being about confirming that the product works, just checking. There's a large test space to cover. Space is currently being covered by shallow manual test cases, that is to say, human checking. These checks took a long time to develop and write up. That's a sunk cost. We don't want to throw them out. Since they're already pretty close to being algorithmic, we can reuse them, even though they're not very valuable. That's one kind of framing. Here's another version of the framing of GEMPUB. Testing is misconceived. Once again, starts with the first two premises. People want to do something to prevent total embarrassment, like a missing screen. Therefore, they'll often settle for showing that something exists and that it can work. And what people do, and it's a reasonable kind of idea to start with, we get a tool to visit every screen, which sounds cheap and it's worth something. And then as long as we can do that, any bugs that might exist are just sort of bad luck. It's hard to find. So here's what I've learned from conferences, books, blogs, and articles and testing forums. The most thoroughly tested part of any application is logging in. And thanks to GimPub, machines can log in hundreds of times a minute, and people will say, "Lo, there be testing happening here." But here's some login stuff that we might want to test. And in order to bring that up, I think I might have to go to a slightly different bit of material here. Where could I look for it? Well, maybe it's in this set here. Let's have a quick look. Oh, bad news. It isn't. So, well, let's bring it up just as a mind map. Here's one tool that I love, by the way. Have you ever seen Search Everything? Anybody know about that? Ooh, that makes my screen disappear. Search Everything is, this is a tool. It indexes absolutely all the files on your machine. So look at that. And it does so in real time. So all I have to do here is type login example, and there it is in the form of a mind map. So I'll bring that up, and I'll bring it up in Mind Manager 23, brand new version of Mind Manager. There we go. And look at this. Here are the ideas that I came up with for testing login. Raw notes. Test strategy ideas, a 1-hour brainstorm I did in 2018 about how I might think about testing a login process. And here's some of the examples of that. Let's make it a little bigger. The authorized user might not be able to log in. The user might have access to, might not have access to permitted resources, might have access to forbidden resources. Unauthorized user will be able to log in. Hacker will be able to get in. A system is vulnerable to some form of attack. Username or password will be intercepted. Some version of the software will be out of date, unpatched, otherwise vulnerable. Login fields, whoops, oh, hang on. Login fields, where is it? Will be vulnerable to known security problems. Error message will be useful, revealed useful information to hackers. User will be revealed into, fooled into revealing credentials, and it goes on and on and on and on. And here's some of the ideas I got to think about. Single sign-in, OAuth. What do I know about logging in anyway? What do I know about related technologies? What are the issues that I got to consider? When does a login test finish? Does the server log the accesses properly? Do we have can we create log files, or are there log files which will allow for non-repudiation, which is one of my favorite aspects of security? Can we depend on the system to track when people do stuff such that they can't deny that they did it? And then here's some of the programmatic elements, some of the product elements we got to think about. Here's all the other stuff that we're thinking about. Here's all the other factors that go into this. And the secret life of automation is that automation can help us with this stuff, but it doesn't do it. So there's all kinds of login stuff that we might want to test, might want to think about. And yet, here's what I haven't learned about. When I see look at our fixation on automated checking, I don't see anything about risk. I don't see anything about problems. I don't see anything about bugs, errors, defects, quality, value, coverage, oracles, investigation, discovery, or learning. I don't see things related to any of this stuff when people are talking about automated checking on the web. That stuff stays secret. Here's the other thing I've noticed. I'll tell this story and then we'll open the floor for questions. I'm going to tell you once again about how I fooled myself. One of the exercises that we used to do in the rapid software testing class was with is a version of the world's best file diffing tool. It's something we found on a site called Code Beautify, and they got the world's best file diffing tool, and we looked at it and we tested it for a little while and we found some bugs. So we developed an exercise based on that. Now, I wanted to produce examples of tools and automated checks that people could use to help test file differ. One example was to rush into automating the product, and James suckered me. James said, tell you what, why don't you write some automated checks for this? So I started with opening the browser and programming some routines to fill in the input fields and find the buttons with the goal of producing really, really simple checks and extending them. I did one simple checks of 2 chunks of text with no differences and another check for a really simple difference. And oh, yay me, great. Now, of course, I ran into testability problems in the product. If you look here, I go up 2 more screens. There are 2 reset buttons. There's one here, and there's one here, and they're both there in the GUI. And that was a testability problem because I had to identify them. They both had the same element ID. So I spent lots of minutes pondering and researching how to get around them because I wanted to be faithful to the scenario that we were giving, not modify the source code. And so, I entered the 9th circle to XPath hell. And then when I actually ran my script, I found out that James had fixed that. He had changed the ID. He'd fixed the testability problem without telling me. So what I found now was that the swell technique that I'd used to locate the second reset button, oh my God, that wasn't going to work because now my test code and James's product code were out of sync, and it's easy for that to happen. So a couple of fiddly hours for me to get some check code running the way I wanted it to. And no doubt, again, if I were programming regularly, that would have gone down to sort of an hour or so. But here's the bad part. At one point, the product was giving me output that I found confusing. And here's what I did. True confessions. I fixed the check code so that the checks ran green. I fixed the check code to match the product's output. I caught myself altering my check code to cope with what the file differ program was doing in a way that made me feel super, super guilty. See, I was avoiding learning how the actual algorithm actually behaved. And it took an embarrassing amount of time for me to catch myself. Now, here's the secret about that. There's significant bugs in the algorithm. And those are bugs that I would have found way earlier if I had confronted the confusion and started to interact with the product and try to learn the product instead of running away from the confusion. We found these bugs by generating representative realistic data, and we found lots more problems by generating volumes of data with interesting patterns using tools. Developing and understanding the product can be hard, and the temptation, remember, I'm somebody who warns people against doing this, and I fell into that trap. So I want to believe that we're all vulnerable to this. Oh, here's another thing. Preparing for a class, I wanted to do a checking demo. I innocently installed Cucumber, which clobbered my Selenium installation. I troubleshot, I hacked, and before I knew it, 4 hours had gone by. And it's not just that it doesn't happen to me alone. Here's Gary Bernhardt, who has written one of the most entertaining presentations on the whole web, WAT, W-A-T. If you look it up on his site, Destroy All Software, And here's what he says. He says, I got active record, no database error, local user with ID 501 doesn't exist over and over until I killed Spring, which was supposed to fix Zeus, which is supposed to fix Spork, which is supposed to reliably amortize Rails setup. Tools like this never work. Phantom.js was so slow that it made programming near unbearable. Now it's gone. So we have CrowDriver instead, and it's even slower. Why is nobody not constantly screaming about all this stuff? It ain't just me, and it ain't just you. This stuff is hard. This stuff is tricky. This stuff is software development. And it seems to me it behooves us to be honest about it. What I think we need to do is when we first encounter the product, remember that ideas about how to test it will be pretty simplistic, not so valuable. And whatever ideas you've got in terms of automating it will be oriented towards demonstration and not so much towards investigation. But we can use checking in an investigative and exploratory way. So my suggestion is engage in testing to learn, explore the product, experiment with it, and then choose to check. Write automated throwaway checks, but don't formalize too much too soon. Because whatever risks you're thinking about, your checks will reflect a naive understanding of what those risks are. So first, focus on learning the product, interacting with it, encountering it naturalistically, and analyzing it so that you can write good libraries of checks that focus on interesting risks and appropriate risks, because half of the stuff you're going to find early on is stuff that is going to get fixed so that the checks themselves will actually work. Okay, long kind of a rambling chat here. Let's open the floor to questions.
Hey guys, sorry, I don't have any questions per se. I do have to run, but I wanted to thank you for a very great session.
I'm still a co-host, so you can go and we can keep things running if you want.
Perfect. No, yeah, I mean, this was very, very useful for me. I'm actually from professional services. I moved to QA to help build a team, and always had this friction sometimes with people thinking it's easy to just engineer and automate test cases, and I've had a hard time kind of explaining some of these concepts. So this was very useful to me.
Oh, great! I hope it was helpful. Thank you.
Yeah, thank you.
I wanted to add to that. I'm QA engineer for the past 10 or 12 years. It seems today in the industry that, automation, adding this automation label for the QA roles makes it more prestige. So a lot of people, especially manual testers, kind of aspire to be there. But the bottom line is that not everything can be automated, and not everything should be automated. And the fact that they added the SDET role now for software developers, so they'll do some automated testing instead of QA testers, makes it even more like, oh, I want to be like them. Why can't I be a software developer? So it's a lot of back and forth, but we shouldn't forget manual testing and the fact that we can find things. And it should be in parallel, basically.
Well, here's what I'm going to say about that, Yossi. I reject the label manual testing, and here's why. Do you know any manual developers? Do you know any manual managers? Do you know any manual parents? Manual scientific researchers? What about, oh, here's one, manual managers, manual journalists, manual designers? All these people use tools, and they use tools in sophisticated and wonderful ways. Why is it the testers allow themselves to be called manual testers? Because testing work isn't manual, it's cognitive, it's intellectual, it's investigative. If a journalist is using a word processor, does that make her an automated journalist? Whereas if she uses a notebook, she's a manual journalist? It's ridiculous.
Yeah, but it comes from the job descriptions, you know.
Well, let's
Uh,
change the freaking job descriptions. That's what I say.
They're
Let
saying
us lobby.
if you're not using code or, you know, the tool, Selenium, etc., then you're not, then you are a manual tester. Like
Well,
that's how it
okay.
looks like in the,
So, well, but that's just dumb. That absolutely belies everything that's important about testing. The fact that you can write code is a wonderful thing. That's great. It's useful. It helps you get stuff done. But that's not what characterizes testing. What characterizes testing is analysis, critical thinking, investigation, experimentation. Do you know about any manual experimenters versus automated experimenters? Are the people who work at CERN manual or automated theoretical physicists? You know, it's just a silly way to think about it. And yet testers have allowed other people to describe us this way. And I think we got to stop. Here's what I'll say, though, as an alternative, a positive alternative for that term. One is experiential testers, people who get experience with the product. We learn about it by experiencing it and interacting with it. So there's another way we could talk about it, interactive testing. If we want to emphasize the things that are going on in real testing work, we could talk about degrees of interaction and how that interaction might be mediated in some sense by tools. But an experiential tester is somebody who interacts with the product in a way that is naturalistic and that reflects the experience of some contemplated user. Or we can say that testing is, certain kinds of testing are by necessity interactive. We need to be there. We need to interact with the product in order to, even if we're running it under script control, to interact with the product and help it if it gets stuck. We need to directly observe the product in its as it's doing its thing. Another thing we could say is that the testing is exploratory, where the testing is not being done under the control of a script or under the control of some preset procedure, but where we're responding in the moment to the testing that's being done. But you know what? Here's something else we could do. We could stop using the word manual. Tester. Nobody talks about manual researchers. Nobody talks about manual journalists. Who had his hand up? I guess he was waving to say goodbye because he's gone now. But just ask me, is any helpful work being done by the term manual? And I'll give you an answer to that. There is one helpful thing, and that is it helps people decide who to pay less.
Exactly.
Right.
Well, that's disgusting, especially since the so-called non-coding skills are skills commonly associated through prejudice and through a stereotype associated with women, because stereotypically women are discouraged by various social forces from getting into programming, which is wrong. It shouldn't be like that, but it is in many respects. And it seems to me that in so doing, what we're doing is we're valuing the capacity to code and paying people extra for it in a way that, once again, we figured out a whole new way to dismiss and to underpay and to undervalue women. Great. Well done, bros. Congratulations. You've done it again. Now, I sound angry about that, and there's a reason for it. I am. Because the social skills,
it's only getting worse.
It's only getting worse. So who stops it? Who stops it, ladies and gentlemen?
We do.
We do. Exactly. Thank you, Billy. We're the ones who put an end to it by rejecting the term manual testing and by saying, yeah, I can code a bit. I code sometimes. If I coded more often, I guess I'd be better at it. but that's not the core, the essence of the work that I do. And if I want some code written, I'll go ask a programmer who can do it with more facility and more immediacy than I can. And we'll work in collaboration. I'll help the programmer by helping the programmer analyze risk, and the programmer will help me by A, crafting little tools for me, and B, helping me learn how to program a little better than I'm able to program on my own today. Rishi, you got your hand up.
Oh, yes. So this is my first session, actually. So thanks to Yusuf for inviting me here. I have a question, and before my question, I want to echo and second your thought about manual tester. It has been exploited terribly in the industry to pay less and what not. Okay, so I second, and I'm with you to start a corrective mechanism to avoid this terminology. And I really echo, somebody or somewhere I got my frustration echoed, and I'm so happy to be part of this group.
Hurrah!
So I'm a career tester myself, and so more than 2 decades I've given here. So my question is, it is a more of progressive mindset on cognitive automation. So what is your, it's not really a question, maybe it is a kind of, I will lower my hand first. So it's kind of maybe a quick discussion or just a food for thought that I want to eat your brain on and take just a bit of a direction. So what do you think towards the cognitive automation or cognitive testing direction? So it is like nowadays it is a little blend of RPA and automation, or RPA and testing is coming into play. So what is your opinion on what should be my food for thought? So that is more of
Well,
yeah.
I worry sometimes about robotic process automation because testing work, it seems to me, is not robotic. If it's robotic, you're probably doing it wrong. Now, of course, there are processes within testing that are amenable to being automated, but why not consider all the wonderful ways in which we could use tools, and I'll put a reference to that in the chat. I've already put 2. I'll put in this one as well, which is why don't we consider how we might use tools in generating test data, in visualizing output, in searching and sorting and parsing through output, in using tools to visualize patterns that we see. There's a last vestiges of this cold I've had. Pardon me for coughing it. And sometimes I kind of swallow my gum when things like this come up. But let's see. How about using tools for setup, which is a kind of robotic process in some sense, for reconfiguring our products? How about using tools? Well, it's okay to use tools to help with the build, to allow us to create builds faster. How about using tools in order to help us search and sort and sift JSONs? James has done some pretty cool work lately using JQ. JQ is a sort of query language for JSON, and it works on the idea that you grab some JSON data and you filter it, and you can search it and sort it in various interesting kind of ways. One of my favorite things recently is something that I started doing on my website when we were doing a redesign of it, and it's something I call automated flagging. It's using similar kinds of techniques to automated checking, but I don't use an automated check to determine whether the output is correct or not. I use tools in order to determine whether a particular blog post that I've got somewhere in my website is interesting from some perspective, maybe because it's got a lot of graphics in it. And in my old website, before my wife helped me to redesign it, my old website had a fairly poor handling of multi-sized graphics. And so I wanted to have a look at that on the new one. And so a page or a blog post that has 25 images in it is more interesting for me to look at from that perspective than one that has none. So I could use that to sift out the web pages that had graphics on them. Similarly, some of the web pages, for reasons I'm not sure why, had iframes on them. So I wanted to look at those because there's a higher level of risk associated with those. I could use tools in order to identify links that were still valid, but that were being redirected. So I could use tools in order to go to that web page, have it suck down all of the URLs that were existing as links on that page, and to see which ones might be missing or broken or redirected, so that I could get those fixed. So automated flagging is this technique that James and I are starting to talk about, which takes advantage of tools for not checking whether something is correct, but whether something is interesting and flagging it for that reason. Billy, your hand's up.
Yes.
Thank
All
you.
right. Yeah, just want to say thanks, Michael. This has been a great presentation. I wanted to go off what Yossi said, and I'm sorry if I'm not pronouncing your name correctly, but I would say that hiring managers that are putting together these job descriptions more than likely don't even know what they're looking for. Right? They're following trends, they're following hype. UI automation, as we all know, is the buzz. Right
Yes.
now. Right.
Imitation is the sincerest form of management, right?
Right. And so what I'm hearing, what you're saying, Michael, is for us to start educating these people, right? Whether they're hiring managers, whether they're our coworkers, anyone that we work with, right?
HR people.
HR people, right? On what testing is. But I wanted to circle back to Yoshi's point is, if we don't market ourselves as quote unquote automation testers, then we are potentially missing out on a larger salary, for example, right?
I don't think so. I think all we have to do is apply and say, yes, I write code. Apparently you're looking for somebody who writes code.
Right. So I guess my question is just, how do we obviously we learn these tools. Maybe we market ourselves as, hey, yes, we can use these tools when we feel like we should use them, right? But I guess it gets to the point where when we are in the interview process that we kind of take over as far as the conversation goes, as far as saying, well, why do you need test automation right now, right? Or what struggles are you having, whatever it is, right?
Well, the question being, what's the problem you're trying to solve?
Right.
And it's I learned a wonderful expression from Jerry Weinberg at one point. There are way too many solution problemers out there. Not problem solvers, solution problemers.
Yeah.
I mean, it was like that with the Agile community years and years ago. There's a whole slew of Agile proselytizers and evangelists who basically what they were saying added up to, if our solution doesn't work for your problem, you should get another problem. Right? So in the world right now, there's this whole tendency to think, how do we solve a problem? Write code.
Yeah.
Well, maybe what we need to do is to analyze the situation. Well, here's the best example I can think of at the moment. I may have to ask for a favor for just a sec because my machine is about to die from battery loss. Just a second. Here's the thank you, Gary, for providing me with emergency plug-in backup stuff. Okay, there we go. Okay, here's the best example I can think of. or at least I was able to think of it just a second ago before that distraction came up. Let's see. Oh, I know. Let me give you this as a vivid kind of metaphor. Imagine that you are responsible for evaluating fire risk and for helping a building manager identify fire risk and to address the problem that, any building has a risk of burning down. All right, so you walk around the building and you have, you got a master key. So you can look into all kinds of places. The first thing you notice is a pile of wood and construction materials lying there in the middle of the hallway. Not only, by the way, such that it could catch fire, but people could just trip over it. All right, you open up a closet door and you look inside, and inside the closet there's oily rags. And then you walk a little farther down the hall, and you open up another door, and you beg, the people's forgiveness, because you open up and it turns out it's a bedroom, but people are sitting there smoking in bed. And then you walk a little farther along, and there's buckets of open gasoline. Open buckets of gasoline just sort of sitting there. And then you also notice that there's a bunch of 15-year-old kids with firecrackers. And you notice as well that the drywall on the building has got lots of holes in it, and the stuffing is coming out. And it's not that modern kind of glass insulation. It's just rolled up newspapers and shirts. Honest to goodness, I lived in a house that had that for a while. When we pried open the drywall, that's what we found. The insulation used by people who weren't so well off, I guess, at some point in the 1920s or 30s when the thing was built. What would you recommend to the builder? Or not to the builder, but to the person who owned the building? It seems to me that your first thing would not be, we should put up more smoke detectors.
Right.
That wouldn't be your first piece of advice. Your first piece of advice would be to say, you probably want to address these combustible building materials and the fact that there's a bunch of arsonists running around.
I'd probably say get really good insurance.
Well, yeah, but even then, that's like telling a development manager, you know what, we should get more liability insurance. I think what we want to do at that point is to say, it might be a good idea for us to clean up our act a little bit and not put up a whole raft of extra smoke detectors, because the smoke detectors aren't going to help with these more fundamental problems. We're already aware of lots of problems.
Right.
And of course, just in case the metaphor isn't landing, if you've got a regression-friendly environment, more regression checks aren't going to help you very much.
Mm-hmm.
Right? They're not going to be very helpful.
I think you bring a good point up, Michael, because I feel that hiring managers right now are they're focused on excuse me, bringing people in to install smoke detectors and alarms, right? And I think it's our job to, when we get on site, I understand that's what you maybe brought me in for, and that's what you wanted. But I've noticed A, B, C, D. I really feel that we should address these first. Not saying that we won't eventually get you your smoke detectors, but
no.
Right.
But let's put the smoke detectors in a place where we don't already have evidence of things that are likely to catch fire. Let's address the fire risk first, and then, since we're already aware of it, we don't need the smoke detector is going to be at best redundant. Yeah. So let's address some of the fundamental problems. And as a tester, I can help developers be alert to problems in all kinds of ways that don't involve me writing automated checks. The first thing I do is give me something to look at, anything to look at, whatever kind of shape it's in. I'm happy to look at it and to identify problems and risks in it such that you're not even going to need to check it, right? That, for example, that bug in the calendar program, once that bug is fixed, once that parse int function is there, wrapping around the values, that bug's never going to come back. We don't need automated checks for that bug. And it's not like developers, to sort of gleefully say, "Oh, the testers found the bug last time and I fixed it, but I'm going to break it again." That they're not rubbing their hands with glee and trying to fool us. So lots of different ways that I can help out to identify risk and problems and be helpful to the developers, participate in reviews, participate in pairing. By the same token, I got to be a little bit careful because my notion of testing, which is focused on recognizing deep, hidden, subtle problems, is going to be different from the developer's notion of testing, because the developer wants to make fast forward progress. Developer wants to move quickly, and the kind of testing that I'm interested in can be kind of disruptive to their process. And I remember 15 years ago, Jonathan Cole, a colleague of mine, reporting the same kind of thing, that developers found him helpful, but a little bit irritating because he was focused on more recherche kinds of risks and not on the ones that the developers really wanted to know about, which is, am I committing easily findable, easily avoidable errors as I'm trying to build this thing? Because I want to keep making progress. And as a tester, I'm happy to go looking for the deep, the rare, the hidden, the subtle, the platform dependent, the condition dependent, the emergent bugs, such that if we were looking for them right now as we were trying to build the product, as the developers were trying to code it, that would be interruptive and disruptive.
Yeah. As far as what Billy said earlier, like in terms of how you represent yourself, I try to represent myself as an exploratory tester who also knows how to code and toolsmith and whatnot. And yes, that means when I do job searches and stuff, I tend to search for test architect,
Right.
SDET type roles. But then when I read those job descriptions, it's like my first level filter. It's like, if it looks like you just want me to take a bunch of manual scripts and automate those, it's one place where I'm context imperial, and like I don't want to talk to that. Yeah, I don't bother applying.
Yep.
And I don't. Yeah, and then for the jobs that seem like they might be flexible, I apply, and assuming I can make it through the kind of like the first barrier is the HR interview, where they want to talk about your Selenium experience, whether or not it's relevant to this job. And I usually tell them, like, yeah, I've got some experience with Selenium, I can use Selenium. It's often not the right choice. It's unlikely that it's the right choice for the team that you seem to be hiring for, but I can do it if I have to. And that's a filter for them, where if they're just looking for somebody to take this batch of things and automate it, then they're gonna not bother calling me again, and I've saved time. And then usually when I get to so I get filtered out a lot at that stage.
And you're lucky to be filtered out in those kinds of circumstances.
Yeah, and then when I talk to a development manager or test manager or director, somebody who's like actually involved with the team, and then I'll start talking about like the HR person said you wanted Selenium stuff, but have you thought about maybe a tool or something to help you populate data, or read the data, or, we can do Selenium, but, it's probably just going to be a handful of those and a lot more under the cover stuff with your APIs, or, I can also help you, spiff up your unit tests if you have unit tests, or get started with unit testing and that sort of thing. Most development managers or test managers, people who are working day to day, really like that. A couple have said, no, we really just want you to take this stuff that we're sending to, some, we're offshoring to some cheap place where manual labor is cheap, to run these scripts, and we really just want you to automate what they're doing. And I was like, well, I can do that, but I'm not going to do that, because that's not going to end up cheaper for you in the long run. And it's also not work that I really want to do. So we can end the interview there if that's what you really want.
It blows my mind, in fact, how people look at low value work and think, how can I pay less for it? Instead of saying, if it's low value work, let's not do it at all, or let's turn it into higher value work. The idea of reducing cost, that's pretty easy. You can reduce cost really, really straightforwardly. Don't do it, right? Don't do that work. If it's not valuable, don't bother with it. But see, what Curtis is talking about is just really nicely put. And what I would also emphasize about that is the interview is not just your opportunity to get hired. It's also your opportunity to avoid getting hired at a place where you don't want to be hired. In other words, what you two are interviewing the hiring people for fit. And that's a big deal. That's a really, really important thing. You want to fit, and you want to help them. If they're not buying what you're selling, get out of there. Don't bother.
Michael, I have a question. What do you foresee for testing the next maybe 5 to 10 years? Where do you see it going?
I am old and wise enough now not to make predictions about it. I can tell you what I'd like to see.
Yeah.
I would like to see, first of all, I would like to see more of the Curtis Pettit kinds of testers, for sure, who are taking a more consultative role, who are exercising technical skills along with testing skills. For those who are not disposed to be coders first and foremost, I have this vision. I heard a second instance of it today, which is just fantastic. I'm working with a client here in Sweden. It's a bank, and one of the senior managers here said, "Oh, well, here's something we do with our testers. We send our testers, excuse me, down to sit with our loan officers, and they sit with the loan officers for a couple of weeks at a time, and they watch and listen to what the loan officers are doing."
Great.
And they become essentially participant observers. And they bring back what they're learning about that domain to the testing group and to the development group, so that they can contextualize the work that the developers are, at least in theory, doing. Another example that I heard from my friend Oliver Wilson in Estonia, who worked on the equivalent of 911 there. His company sent him again for a couple of weeks to sit with 911 operators, gave him a headset, no microphone, said, just watch what they do, listen to what they do, watch how they use our software, watch how they interact with it. Don't talk to them while they're working. We'll give you time to debrief. and we've set things up so they'll have half an hour to an hour a day so that they can, walk through what they're doing with you, air any questions. You can obviously go have coffee breaks with them, and you can have lunch with them, and you can go to dinner with them if you like, no problem there. But what we really want you to do is we want you to pay attention to how they're working and the kinds of things that they consistently stumble over or give you feedback about, where the software isn't helping them and isn't following their task. So the idea, I hope, is that testers become, some testers at least, become more like anthropologists, social scientists, sociologists. And that's great for people who are of a research-oriented, analytical kind of bent, but who are nonetheless not that jazzed by programming. Bring that to the testing world, because that's what we're sorely lacking at the moment.
Yeah.
The capacity to analyze and to a different kind of coding, the kind of coding that they use in qualitative research, which is not writing program code, but arranging and classifying observations and categories of behaviors and of work that people do, and of moments within their work, that arranging stuff in those kinds of tables.
All right. Thank you, Michael. So we are like 30 minutes over than our planned time, but I hope
Welcome to my
everyone
world.
is enjoying. Yeah. So I like the way you said about the real tester is the person who will do the analysis, critical thinking, and the experimentals. And
Risk
that's
investigator.
what describes
Yep.
a good tester. And I couldn't be more agree with that. And the idea of if the solution is not solving our problems, we need another problem, which is also correct in the real world, And so lots of good things were discussed by you today. And I would like to thank you for the great presentation. And please check Michael's blog at developsense.com and his work at rapid-software-testing.com. And thank you again, Michael, for the great presentation.
Please feel free to get in touch if you like.
That's absolutely.
Lifetime free technical support for this talk.
And obviously these recordings will be posted to our YouTube channel as well shortly. I mean, maybe today or tomorrow. And please go ahead and rewatch the session again if you'd like. And on behalf of our Houston Software Quality Engineering Group and our presenter, I would like to thank everyone for joining the call and wish you enjoy the rest of the day. Thank you, guys. Thanks, Michael.
So long, folks. Thank you very much. All the best.
Yeah, appreciate it. Thank you.
Bye-bye.